What if I told you that every mountain on Earth used to be a tree? Not a metaphor, not ancient folklore, an actual tree, towering miles into the sky, wide enough that entire civilizations could live inside the trunk. Devil's Tower in Wyoming, a petrified stump, the Matterhorn, cut down, Mount Roraima in Venezuela, the fossilized remains of what used to be a living organism so massive it makes redwoods look like weeds. And if these mountains are stumps, then the forest they came from would have been incomprehensibly large. Large enough to fundamentally rewrite everything we know about Earth's history, geology, and the forces that shaped our planet. This theory exists. It has millions of believers, and today we're investigating whether there's any truth to it, or if it's the most elaborate misunderstanding of geology ever conceived. Let's start with the most famous piece of evidence, Devil's Tower. Rising 1,267 feet above the Wyoming plains, it's made of hexagonal columns of igneous rock that look almost too geometric to be natural. The official explanation? It's the remnant of a volcanic intrusion that cooled and cracked into these bizarre columns. The cooled magma hardened while still underground, and over millions of years the softer rock around it eroded away, leaving this tower standing alone. But here's where believers in the ancient tree theory push back. They point to the columns and say, those aren't cooling cracks. They're the fossilized cellular structure of a tree trunk. They point to the flat top and say that's where it was cut. They point to the debris field around the base and claim those are the remnants of bark and branches that fell away as the stump petrified over time. And honestly, if you look at it without any geological training, it's not a crazy leap. The columns do look organic. The symmetry is unsettling. And there are actual fossilized trees that show similar columnar patterns when they petrify, just on a much smaller scale. So the question becomes, is this a case of pattern recognition gone wild, or is there something geologists are missing? The theory didn't start with Devil's Tower. It started with a Russian researcher in the early 2000s who began cataloguing geological formations that seemed too regular, too structured, too symmetrical to fit the chaotic processes of erosion and tectonic activity. He looked at flat-top mesas, at hexagonal columns, at the specific mineral compositions of these formations, and he asked a simple question. What if we've been categorizing these wrong the entire time? His hypothesis was that Earth once had a radically different ecosystem. Trees that were miles tall, supported by a different atmospheric composition, possibly higher oxygen levels, possibly lower gravity. These trees would have been the dominant life forms on the planet, creating forests so dense and so massive that they shaped weather patterns, controlled erosion, and dominated the landscape in ways we can't even imagine today. Then something happened. A cataclysm, maybe a meteor impact, maybe a shift in atmospheric composition, maybe a war if you believe some of the more fringe versions of this theory. But whatever it was, it brought the trees down. And over millions of years, the organic material petrified, mineralized, and turned into what we now call mountains. Now let's address the biggest problem with this theory. Petrification doesn't work that way. When organic material fossilizes, minerals replace the tissue cell by cell. This works for small objects like trees, bones, shells. But for something the size of a mountain, the internal pressure, heat, and mass would cause structural collapse long before petrification could occur. A miles-tall tree trunk wouldn't turn to stone. It would rot, collapse, and disappear. Geologists point this out constantly. They also point out that the mineral composition of Devil's Tower and similar formations matches volcanic activity perfectly. The crystals are arranged in ways that only happen when molten rock cools. The layers match the predicted flow patterns of magma. The surrounding geology supports the intrusion model. There's no mystery here, they say. It's just basic igneous petrology. But here's where it gets interesting. Believers in the ancient tree theory aren't just random conspiracy theorists. Some of them have backgrounds in engineering, architecture, material science. And they point out that our understanding of petrification is based on modern conditions. If atmospheric pressure was different, if the chemical composition of the environment was radically different, if there were biological processes we no longer see today, then maybe petrification could occur on a much larger scale than we currently believe possible. They also point to the Giant's Causeway in Northern Ireland, another hexagonal column formation, another site where the official explanation is volcanic, but the symmetry is so perfect that it looks designed. They point to the basalt columns in Iceland, in Scotland, in dozens of locations around the world where the same pattern repeats. And they ask, why is this pattern so common? Why does it show up on every continent? Is it really just coincidence, or is there a biological template we're missing? One of the strongest pieces of evidence they cite is the sheer scale of some of these formations. Mount Roraima in Venezuela is a flat-top mountain that rises abruptly from the jungle. The top is a plateau, the sides are sheer cliffs, and the whole thing looks like it was sawed off at the top. Geologists say it's a tepui, a type of table mountain formed by erosion of softer rock around a harder core. But the tree theory believers point out that the top is almost perfectly flat, the edges are almost perfectly vertical, and the surrounding debris field contains minerals that don't match the erosion model. They also point to the fact that the top of Mount Roraima has unique species of plants and animals that exist nowhere else on Earth. Species that seem adapted to an isolated environment, as if they evolved on top of a structure that was once much taller and connected to a broader ecosystem. The official explanation is that these species evolved in isolation after the plateau formed. But the tree theory asks, what if they evolved on top of a living tree, and they're the remnants of an ecosystem that existed in the canopy of an ancient forest? Now let's talk about size. If Devil's Tower is a stump, how big was the tree? Based on the proportions of modern trees, where the stump is roughly 10 to 20% of the total height, a tree that left a stump 1,267 feet tall would have been somewhere between 6,000 and 12,000 feet tall. That's over 2 miles. For context, the tallest tree alive today, a coastal redwood named Hyperion, is 380 feet tall. We're talking about trees that would have been 30 times taller than the tallest trees alive today. And if you apply that same logic to larger formations, the numbers get even more absurd. Mount Roraima is 9,220 feet tall. If that's a stump, the tree could have been anywhere from 9 to 18 miles tall. That's taller than commercial airliners fly. That's into the stratosphere. And if you apply this to the largest mesas and plateaus in the world, you're looking at trees that would have reached the edge of space. The believers in this theory have catalogued dozens of potential stumps worldwide. There's the Brandberg Mountain in Namibia, a massive granite dome rising out of the desert with a distinctly circular footprint. There's Mount Connor in Australia, often mistaken for Uluru, with its flat top and sheer sides. There's the Tepui formations throughout Venezuela and Brazil, each one looking like nature took a cleaver to the top of something that used to be much taller. Each of these formations has official geological explanations. Brandberg is a granite intrusion that cooled underground and was exposed by erosion. Mount Connor is a mesa formed by differential erosion of sedimentary layers. The Tepui formations are remnants of a massive sandstone plateau that once covered the entire region before erosion carved it into isolated table mountains. All of these explanations are supported by mineral analysis, stratigraphic studies, and decades of field research. But the tree theory believers look at the sheer number of these formations and ask a simple question. Why are there so many flat-topped mountains? If erosion is random and chaotic, why does it create the same pattern over and over again? Shouldn't we see more variety in mountain shapes, more irregular peaks, more asymmetric structures? Geologists have an answer for this too. Flat tops occur when there's a resistant cap rock on top of softer layers. The hard cap protects the softer rock beneath from erosion, creating a plateau. As the surrounding landscape erodes away, the plateau stands higher and higher, eventually becoming an isolated mesa. This process is well documented in places like the Colorado Plateau, where you can literally watch it happening in geological time. But here's where the tree theory gets more sophisticated. Some believers aren't claiming that all mountains are stumps. They're saying that certain specific formations show patterns that don't fit the erosion model. They point to the fact that many of these flat-top mountains have remarkably consistent heights within a given region, as if they were all cut at the same level. They point to the mineral composition of the debris fields around these formations, claiming that the ratios of certain elements match what you'd expect from decomposed organic material, not eroded rock. They also point to something called the columnar jointing paradox. Hexagonal columns, like those at Devil's Tower or the Giant's Causeway, form when lava cools and contracts. The standard model says this happens because the cooling creates thermal stress that fractures the rock in the most efficient geometric pattern, which happens to be hexagonal. But some materials scientists have pointed out that biological structures also favour hexagonal patterns because they're the most structurally efficient way to pack cylindrical cells together. Honeycomb is the most famous example, but plant stems, bone marrow, and even some tree trunks show hexagonal cell packing under microscopy. Biologically, this is impossible under current conditions. Trees are limited in height by the physics of water transport. They use capillary action to pull water from the roots to the leaves, and there's a hard limit to how high that process can work before gravity wins. For Earth's current atmospheric pressure and gravity, that limit is somewhere around 400 to 450 feet. Anything taller would require a fundamentally different biological system or a fundamentally different environment. But here's where the theory gets creative. Believers point out that Earth's atmosphere hasn't always been the same. During the Carboniferous period, roughly 300 million years ago, oxygen levels were as high as 35% compared to 21% today. This allowed insects to grow to enormous sizes. Dragonflies with 2-foot wingspans, millipedes the size of cars. If higher oxygen levels allowed arthropods to grow larger, why couldn't they allow trees to grow taller? The problem with this argument is that it misunderstands how oxygen levels affect organism size. For arthropods, higher oxygen is critical because they don't have lungs. They breathe through a network of tubes called tracheae that deliver oxygen directly to their tissues. The efficiency of this system is limited by the diffusion rate of oxygen through the tubes. Higher atmospheric oxygen means oxygen can diffuse deeper into the body, allowing for larger body sizes. But this effect has hard limits. Even at 35% oxygen, you're not going to get a millipede the size of a bus. For trees, the limiting factor isn't oxygen at all, it's water. Trees don't actively pump water up their trunks. They rely on passive capillary action and transpiration. The evaporation of water from the leaves creates negative pressure that pulls more water up from the roots. This system works beautifully up to a certain height, but physics puts a hard cap on it. At sea level, with current atmospheric pressure, you can't lift a column of water higher than about 400 feet through capillary action alone. The weight of the water column becomes too great and the system fails. Now, believers in the tree theory argue that if atmospheric pressure was higher in the past, the water column could be taller, and they're technically correct. Higher atmospheric pressure would increase the efficiency of capillary action. But the effect is small. You'd need atmospheric pressure significantly higher than what we see today, maybe twice as high, to support a mile-tall tree. And there's no evidence in the geological record for atmospheric pressures that high in the time frame we're talking about. They also point to theories about Earth's gravity. Some fringe models suggest that Earth's mass has increased over time due to cosmic dust accumulation or expansion of the planet's core. If gravity was lower in the past, then the height limit for trees would have been much higher. A tree growing under half of Earth's current gravity could theoretically reach twice the height before hitting the water transport limit. But this is where the theory runs into serious problems. The expanding Earth hypothesis has been thoroughly debunked. GPS measurements show that Earth's radius is not increasing. Tidal patterns, orbital mechanics, and the behavior of the Moon all constrain Earth's mass to within very narrow bounds that haven't changed significantly in billions of years. If Earth's gravity was dramatically different just a few million years ago, we'd see evidence of it everywhere. Fossil bones would have different structural properties. Impact craters would have different shapes. The moon's orbit would be measurably different. None of these things are observed. What we do observe is a fossil record that's remarkably consistent with current gravitational and atmospheric conditions. The largest land animals ever, the sauropod dinosaurs, pushed the limits of what's biologically possible under Earth's current gravity. Their bones show adaptations to support immense weight, air sacs to lighten their bodies, massive leg bones with internal structures optimized for compression loading. And even with all these adaptations, the largest sauropods were probably right at the edge of what's physically possible. They didn't exceed it because they couldn't. The same constraints apply to trees. The tallest trees that ever existed were probably not much taller than the tallest trees alive today. The fossil record supports this. We've found fossilized trees from the Carboniferous period, and while they were impressive, they weren't miles tall. The tallest were maybe 150 to 200 feet, which is well within the range of modern conifers and eucalyptus trees. So if the biology doesn't support mile-tall trees, and the physics doesn't support mile-tall trees, and the fossil record doesn't show evidence of mile-tall trees, what are we left with? We're left with mountains that look like they could be stumps if you ignore everything we know about how mountains form and how trees grow. Mainstream science rejects both of these ideas. The oxygen levels during the Carboniferous were higher, but not high enough to support multi-mile tall trees. And there's no credible evidence that Earth's gravity has changed significantly in the last few 100 million years. The fossil record shows a consistent relationship between organism size and environmental conditions, and nothing suggests the kind of radical gigantism required for mile-tall trees. But the tree theory believers aren't done. They point to myths and legends from cultures around the world that describe massive trees connecting Earth to the heavens. The Norse had Yggdrasil, the world tree. Hindu cosmology describes a cosmic tree that supports the universe. And then Native American legends speak of a great tree that was cut down by gods or giants. These stories exist on every continent, in cultures that had no contact with each other. Coincidence, or cultural memory of something that actually existed? Anthropologists would say these are archetypal myths. The tree is a universal symbol of life, growth, and connection between earth and sky. It makes sense that cultures would independently develop stories about cosmic trees. It doesn't mean those trees actually existed. It means the human brain is wired to think in symbols and metaphors, and the tree is one of the most powerful metaphors we have. But the believers push back. They point out that many of these myths aren't vague. They're specific. They describe the trees being cut down, the stumps left behind, a world radically different before the trees fell. And they ask, if these are just myths, why are they so consistent across unconnected cultures? Now let's address the elephant in the room. If these mountains are stumps, where are the tools that cut them down? Where are the remains of the trunks and branches? Where is the evidence of a civilization or force capable of felling trees that size? The tree theory has an answer for this, and it's where the theory splits into different camps. One camp says the trees were brought down by a natural cataclysm, a meteor impact, a massive solar flare, a shift in Earth's magnetic field, something that caused catastrophic environmental collapse, killed the trees, and erased most of the evidence. Over millions of years, the trunks and branches decomposed or were buried, leaving only the stumps that were large enough and dense enough to petrify and survive. Another camp says the trees were cut down intentionally. By whom? This is where it gets wild. Some say an advanced pre-human civilization. Some say extraterrestrials, some say giants, pointing to myths and legends about giant beings that once walked the earth. The stumps, they argue, are the evidence. The fact that the tops are flat isn't erosion, it's proof of deliberate cutting. Mainstream geology has a much simpler explanation. These formations aren't stumps. They're the natural result of well-understood geological processes. Volcanic intrusions, erosion, tectonic uplift. The patterns we see, hexagonal columns, flat tops, vertical cliffs, all of these have documented explanations that don't require rewriting the laws of physics or biology. But here's the thing. Mainstream geology has been wrong before. Continental drift was considered fringe pseudoscience until the 1960s, when plate tectonics became the accepted model. Meteorite impacts were dismissed as impossible until the Chicxulub crater was discovered and confirmed as the cause of the dinosaur extinction. Science progresses by questioning assumptions and following evidence, even when that evidence challenges the consensus. So what's the evidence here? The tree theory believers point to the formations themselves, the symmetry, the scale. The mineral composition that they claim doesn't match the volcanic model as cleanly as geologists say it does. They point to the myths and legends. They point to the biological plausibility under different atmospheric and gravitational conditions. They point to the fact that science doesn't have perfect answers for everything, and maybe this is one of those gaps where the consensus is wrong. But here's the problem. Extraordinary claims require extraordinary evidence. And the evidence for ancient mile-tall trees isn't extraordinary, it's speculative. It relies on reinterpreting data through a lens that requires assuming multiple unproven things, higher oxygen levels, lower gravity, unknown petrification processes, advanced civilizations, or cataclysmic events that left no other trace. That's a lot of assumptions. And when you stack assumptions like that, the burden of proof gets heavier with each one. You're not just asking people to believe one thing, you're asking them to believe an entire alternate history of Earth that contradicts multiple fields of established science. Geology, biology, physics, chemistry, all of them would need to be revised to make this theory work. That doesn't mean it's impossible. But it does mean the evidence needs to be ironclad, and right now it's not. The formations that look like stumps can be explained by conventional geology. The myths and legends can be explained by universal human symbolism. The biological challenges can't be overcome without invoking environmental conditions we have no evidence for. But let's entertain the theory for a moment. Let's say it's true. Let's say Earth once had forests of mile-tall trees. What would that world have looked like? The canopy would have been in the stratosphere. Weather patterns would have been completely different. Rainfall would have been trapped in the upper layers of the forest, creating rivers that flowed through the branches before ever reaching the ground. The ground level would have been in perpetual twilight, lit only by filtered light from miles above. Ecosystems would have evolved around these trees. Birds, insects, mammals, all adapted to life at different altitudes within the forest. The trunks themselves would have been entire ecosystems with species that lived their entire lives moving up and down the bark, never touching the ground or the canopy. The roots would have been networks the size of cities, anchoring the trees and pulling nutrients from deep within the Earth's crust. Think about what it would mean to live in a world like that. The lower levels of the forest would be a dark, humid environment where decomposition happens slowly and fungi dominate. The middle levels would be where most of the animal life concentrated, where there's enough light for understory plants, but still protection from the harsh conditions at the canopy. And the upper levels, the canopy itself, would be a world of constant wind, intense sunlight and temperature extremes. Species would have stratified by altitude. You'd have ground-dwelling creatures adapted to low light and high humidity. Mid-level creatures that could climb but rarely ventured to the extremes. And canopy specialists that never descended, living their entire lives in the sunlight miles above the forest floor. The evolutionary pressures in each zone would be completely different, creating biodiversity on a scale we can barely imagine. And the trees themselves, if they were biological organisms and not just geological formations, would have needed adaptations we don't see in any living tree. Their trunks would need to be incredibly strong to support their own weight. They'd need vascular systems capable of moving water and nutrients over vertical distances of miles. They'd need root systems that could anchor against winds strong enough to topple structures that tall. They'd need bark thick enough to protect against temperature fluctuations between ground level and the stratosphere. Some believers point to silicon-based biology as a solution. They argue that these weren't carbon-based trees like we have today, but silicon-based organisms that could incorporate minerals directly into their structure as they grew, making them stronger and more resistant to the physical stresses of extreme height. This would explain why they petrified so completely. They were already partially mineralized when they were alive. But silicon-based life is purely hypothetical. We've never found any evidence of it on Earth or anywhere else. Silicon can form some of the same types of bonds as carbon, but it doesn't have the same versatility. Silicon-silicon bonds are weaker than carbon-carbon bonds, and silicon doesn't form stable long chains the way carbon does. Every model of silicon-based biochemistry runs into fundamental problems that make it unlikely to work in practice. And if something brought that forest down, the ecological collapse would have been total. The sudden exposure to direct sunlight, the loss of the canopy rainfall system, the decomposition of billions of tons of organic material releasing carbon and methane into the atmosphere. It would have been an extinction event on a scale that makes the dinosaur extinction look small by comparison. You'd expect to see a boundary layer in the geological record, a distinct line where suddenly everything changes. Below the line, evidence of the old ecosystem. Above the line, evidence of the new. We see exactly this kind of boundary at the end of the Cretaceous period, the K-T boundary, where a thin layer of iridium-rich clay marks the asteroid impact that killed the dinosaurs. If mile-tall trees collapsed all at once, there should be a similar boundary layer showing massive carbon deposits, sudden changes in sedimentation patterns, and evidence of catastrophic ecological disruption. But we don't see that. The geological record from the periods when these formations were created shows normal, gradual changes, slow shifts in climate, predictable patterns of erosion and deposition, no sudden catastrophic boundaries that would indicate the collapse of a global forest system. This is the central problem with the theory. It requires rewriting not just one thing, but everything. And when a theory requires that much revision of established knowledge, the evidence needs to be overwhelmingly convincing. So far, it's not. But that doesn't stop people from believing it, because there's something deeply appealing about the idea of a lost world. A world that was bigger, stranger, more magnificent than anything we can imagine today. A world where the landscape itself was alive in ways we can barely comprehend. And maybe that's what this theory is really about, not geology or biology or physics, but a longing for mystery in a world that feels increasingly explained and mapped and understood. Because here's the truth. We do live on a planet that was once radically different. The Carboniferous forests were alien. Oxygen levels were higher. Insects were massive. The continents were arranged differently. The climate was warmer. And yes, there were trees larger than anything alive today. Not miles tall, but large enough that their fossilized remains still astonish us. And maybe that's enough. Maybe we don't need mile-tall trees to feel wonder at the Earth's history. Maybe the actual story, the real story of how this planet evolved and changed and created the world we see today, is strange enough and beautiful enough without needing to invent ancient forests that reach the stars. But if you still believe that Devil's Tower is a stump, if you look at Mount Roraima and see a sawed-off trunk, if you think there's something geologists are missing, then ask yourself this. What evidence would convince you otherwise? What would it take for you to accept the conventional explanation? Because if the answer is nothing, if no amount of geological data or biological analysis could change your mind, then you're not investigating a theory. You're holding on to a belief. And beliefs don't need evidence. They just need to feel true. So where does that leave us? With mountains that look like stumps, with myths that describe cosmic trees, with a theory that's compelling in its imagination, but lacking hard evidence. And with a reminder that the world is full of mysteries, even if this particular mystery has a more mundane explanation. If you made it this far, you're the kind of person who questions things, who wants to dig deeper, who isn't satisfied with surface answers. Subscribe if you want more deep dives into theories that challenge what we think we know. The world is stranger than we imagine, even if the mountains aren't stumps.